All right, so these are our notes on valence electrons and Lewis dot structures. So if you don't have your Cornell notes template open, go ahead, go to Classroom, click on Classwork, Unit 6, and you're going to go down and find the Lewis dot and valence electron notes assignment. Open it up so that you can get a hold of the one that has your name on it, and it will be, again, Cornell notes. All right, so let's go ahead and get started. All right, so Lewis dot structures and valence electrons. So we're going to talk about first how to find valence electrons, and then you'll see exactly why I made you do your Bohr model a certain way as we learn how to make Lewis dot structures. All right, so our essential question here is what is a valence electron and how to draw a Lewis dot structure. The definition of a valence electron are the electrons in the outer energy shell are called valence electrons, and the S and P orbitals are the only ones that hold them. They're those outer highest energy level ones. And you do not count the electrons on the inner energy shells for valence electrons. So those inner circles do not count. We're just talking about that outside circle from the Bohr models. And only valence electrons are involved in bonding. Okay. There's two different ways to determine the number of valence electrons, and I'll go over both of them here. The first one is to determine the group the element is in. So we have our S block and we have our P blocks here, and each one of these groups, these columns, will tell us how many valence electrons each of them have. The second way is to determine it from the electron configuration. Okay. All right, so let's look at way number one. So number one is group valence electrons. So we have them highlighted here. And each element in a group has the same number of electrons in their outer orbital, are also known as shells. Only electrons in the S and P orbitals can be valence electrons. So you can see in group one, so this whole column, all these elements down here have one electron in their outer shell. And of course it's an S1, and group 2 has 2. We skip over these because these are all lower energies level orbitals here. Group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and most of the ones in group 18 have 8, except for helium. Remember, that's always our exception to the rule. Helium only has 2. So notice, I'm just taking the ones from each group number, and that's how many valence electrons it has for these one over here, for 13, 14, 15, 16, and 17. So that's one way of telling. You can also just count. If it's an element here, like in group 15, you would just count from the left side, 1, 2, 3, 4, 5. Also tells you, okay? All right, so you can also figure out from valence electrons from the electron configuration. You will write out the electron configuration and then add the exponents of the highest energy levels together to get the total. So here's some example. Here is the electron configuration of nitrogen. Our highest energy level is 2 here, so I'll underline each of those, the S and the P. And then you have an exponent of 2 and 3. You would add those together to get a total of 5 valence electron. And nitrogen is in group 15. Sulfur, here's the electron configuration. You would underline the highest energy level, which is 3. You have the 2 exponents here, 4 and 2. You add them together to get 6. All right, so now that we know how to find the valence electrons, the next thing we want to do is how do we make a Lewis dot structure representing them? So Lewis dot structures are used to visually represent the number of valence electrons, and here are our steps. The first step is to locate your element on the periodic table. The second one is to determine the number of valence electrons. The third is write the element symbol and then add the valence electrons around the symbol. I'll show you how to do that. You will always start at the top and move counterclockwise. Only pair electrons after there's one on each side of the symbol. Seems kind of familiar to those outside Bohr rings, doesn't it? All right, so let's look at an example. We're going to use carbon, and carbon is in the 14th group, but the first thing is we write the element symbol. It is a C, and it's in the 14th group, 14, so it has 4 valence electrons. So we're going to start at the top and draw 4. So 1, and go counterclockwise, 2, 3, and 4. That is the Lewis dot structure for carbon. Okay. All right, let's look at another one, phosphorus. So phosphorus is in group 15. Its symbol is a P, so I'll write that first. And I'm going to do 5 valent electrons. We're going to start at the top and go counterclockwise. So here we go. 1, 2, 3, 4. So now that I have one on each side, I will start pairing them. And so my 5th one goes up here for 5. So this is the Lewis dot structure for phosphorus. All right, so now I want you to pause the video. I want you to, on any piece of paper you can, go try to make these on your own. So hydrogen, oxygen, magnesium, and argon. All right, so hopefully you stopped and tried it on your own. You can check it here. So your hydrogen should look like this. Oxygen should look like this. Magnesium should look like this. And argon should look like this. All right, so that's the end of our notes. So go back and you're going to highlight any important notes. You're going to make connections to any of your notes in the left-hand column. You're going to write any questions you may have in the left-hand column. And then use your highlights, connections, and questions for your summary. And make sure that you're writing a 3 to 5 sentence summary at the end. Once you do that, go ahead and turn your notes in.